It's question show time. Your questions, my answers. As always, wherever you are, anywhere across my channel, if a question pops into your brain, write it down. I'll gather them up and I will answer them here. We've got a special guest answerer again this week, so stick around to the end. All right, let's get into it. Yodako Okadoi. I have asked before, I don't think it's been answered yet. How do we know that a meteorite came from Mars or any other body for that matter? Seems like we're just jumping to conclusions when we say, oh yes, this is a Mars meteorite. Thanks for making all this content for the world to enjoy. So in order to determine that a rock came from Mars, planetary scientists, meteorite researchers take the rock and in a very careful environment, they slice it open. And there's gas trapped in tiny little pockets inside the rock, and they were put there when the rock first formed. You can kind of imagine, right? You've got this lava flow, and it's forming these rocks that are burbling out onto the Martian surface, and it is trapping atmospheric gases inside the rock. And then you get more and more rock, and then it's sealed inside. And then some gigantic asteroid hits Mars, blasts all this material out into space, including some of these, Mars rocks are able to make this entire journey through the solar system and eventually crash into the Earth. They can make it through the atmosphere and they land on the surface. And so meteorite researchers, they go out to places like Antarctica and they drive in snowmobiles for days on end, and they're looking for any rock that's sitting on the top of the ice sheet, because this is a place that rock shouldn't be. And they're able to pick up these meteorites. They also look in deserts, places where it should just be sand. So if you see some weird rock sitting there, then it's most likely a meteorite. And each one of these meteorites, they sample them, they slice them open, check for gas, and determine, based on the composition of the gas inside the rock, where it came from. Because we know with all of the spacecraft that are on the surface of Mars now, with Curiosity and Opportunity and Spirit and the Viking missions, they understand very carefully what the composition of the Martian atmosphere is. And so they open up the rock, determine the atmosphere. It doesn't match Earth atmosphere, it actually matches Mars atmosphere, and that tells them that the rock came from Mars. It's amazing. Eric V. Why would an astronomer ever intentionally try to look for extraterrestrial intelligence? My God, the naivety. I can understand trying to find habitable Earth worlds, but to go out of your way to look for technosignatures is... What do you suppose would happen if you did find that? Just honestly, think about it for a second. Let it happen accidentally, sure. But you have to be an anti-human nihilist to intentionally seek it out. Yes, it'll only be a one-sided until we know about them and not the other way around, but people are emotional, and it's only a matter of time until someone or some faction sends them an intentional message. That, or only look in locations that are too far away to be a threat to us. I've covered this topic many times in the past, so I think it's time to let you in on a little bit of a secret. Is that if there are any aliens out there within an enormous radius, they already know we're here, right? You were talking about biosignatures. Life itself has been pumping out the chemicals into the atmosphere for 500 million years, since the oxidation event. And any aliens out there who are in the process of building James Webb telescopes, LUVOIR telescopes, super LUVOIRs, they will be able to analyze Earth and detect the presence of life on this planet. And in fact, if they're within a couple of hundred light years, they're going to be able to detect the presence of the kinds of pollution that our modern society puts out. Match that, even more careful observations, they can start to see even more stuff. Like, for example, the radio telescope that people are building right now, the Square Kilometer Array, that would detect airline radio traffic within, I think, 100 light years. So that secret is out, right? And so if anyone wants to try and communicate with some alien civilization out there that is within some sphere of influence, the aliens already know that we're here, just as we're about to find out where they are. So unfortunately or fortunately, the secret is already out. And so the kind of amazing part is the aliens haven't come to take our water yet. I think so if that's your concern, that horse has already left that stable. If your concern is like we human beings can't handle the knowledge that there are aliens, relatively nearby to us, I think you overestimate how bored people can become of the most amazing, incredible things. I think people will freak out, they'll get really excited for a while, then they'll get bored, then they'll go about their lives, and they won't even think about it. And I think that that it would be the most incredible discovery for a while, but people got to live, and they'll just keep going on with their lives. So don't worry, the aliens already know we're here, and we're about to know they're there. James Bassett. I keep hearing people say that our solar system is unusual because nearly all the other solar systems we can see have large planets orbiting close into their sun. But isn't it more correct to say that our current technology means we are far more likely to see large planets with close orbits, so the dataset could be just as easily a result of observational bias? Sort of. The first planets that astronomers found, like the one at 51 Peg, these hot Jupiters, were discovered a little early because the scale of these planets, the size, and how close they are to their parent star was not something that astronomers were ever predicting. They never thought that you would find planets with many times the mass of Jupiter orbiting well within the orbit of Mercury. They were a surprise. They were using this technique, they were trying to find planets, and what do you know, this super weird kind of planet comes about. And now astronomers have found more and more of them as they look around. And you're exactly right, though. By the nature of the technology, we're only going to find the planets that are relatively close to their stars, that orbit on a very rapid basis, where you can make repeated observations and really get a sense of what the scale and the size of the planet is. And that's just the nature of discovery. You start by discovering the low-hanging fruit, and then over time, you discover other stuff that's harder and harder to find. And it might be that things like the transit method and the radial velocity method, we're going to reach their limits, right? We're only going to be able to find something like, say, the Earth. And then beyond that, you're not going to be able to find a Mars, and you won't be able to find a Jupiter just because it takes so long to orbit its star. Like, how do you make observations when something takes 15 years to go around its star, like Neptune, right? More than 100 years. But there are other techniques that are going to come along after that. You've got like the direct imaging method, where you have a gigantic, powerful telescope like LUVOIR, which can take a direct picture, block out the light from the star, and see all of the planets that are orbiting around that star directly. Doesn't matter if they're lined up face on. And so this next generation of super space telescopes will have completely different capabilities and open up different options. But I think what it's safe to say so far is that astronomers are finding enough strange star systems, different star systems out there, to show that there is a ton of variety out there in the kinds of worlds that you can get, their distances, their configurations, and this is really exciting. And so over time, with more observations, with better telescopes, we're going to get a much better sense of what is average, what is normal, what can we predict, what do we see. So stay tuned. Chris March. You've mentioned that computer science is the most versatile degree for getting involved in all things space. Are there any exciting projects that could use a software engineer and that you would recommend? I suspect that there are an open source or citizen science project that might be a good place to start contributing, but there are so many I don't know where to start. I've been programming video games professionally for almost 20 years, and I specifically enjoy programming simulations, graphics, math, and games. I mean, I can recommend lots of citizen science projects. There's, of course, CosmoQuest, which I'm involved in. Go to cosmoquest.org. There's the Zooniverse, which does the Galaxy Zoo and a lot of other great projects. There's SETI at Home. So there are a bunch of projects that you could look up and very quickly get a chance to, to get involved with. But I think, you're not going to know which is the one for you until you just join their communities, understand how it works. If you come to CosmoQuest, we'll put you to work trying to find and identify boulders on the surface of Bennu to try and help with the landing. I think if you go to Zooniverse, they've got like a planet hunters to help try and find extrasolar planets. And there's this next generation of super space telescopes and ground telescopes like the Large Synoptic Survey Telescope, which are going to be dumping just enormous amounts of data onto the internet, and someone's going to have to go through it. So I can't tell you which is the one that's going to be right for you. I can tell you that there are a ton of them. You can search citizen science, astronomy. You'll find organizations, join their discussion forums, get involved in their projects as they stand today. And if you've been working in this kind of field for a while, great ideas will come into your brain. You'll realize how you can play a part. And sooner than later, you will have more responsibilities than you know what to do with, which, That's how I like it. Kenny Ulan. Well, come on, really? Nice idea, but not worth the time. We haven't found an amoeba yet anywhere else, and you're thinking super platinum planets? You can do better. Well, for starters, these videos aren't for you. But second, I see a lot of the time people misunderstanding using your imagination and thinking of ideas and actually making things, right? So on the one hand, someone sits down and goes, I wonder if there are any of the parts of Earth that make this place habitable that could be more habitable in some other planet. What about the current systems? What about the mountains? What about plate tectonics? What about the habitable zone? And each one of those things that you think about, and you just you think and you write them down and you do some math and you write a paper and it's interesting and other people look at it and go, it's pretty interesting, right? That is not practical today, right? But that's how science works. Yeah. Maybe later on, very far into the future, we will develop really powerful telescopes and do these really detailed surveys, and we'll find these planets that are orbiting other stars. And based on this paper, these make predictions that people are able to find these super habitable worlds. And then we build a spacecraft and it crosses the gulf between Earth and these other star systems. And it takes 1,000 years, and there's generations of people who live and die on these ships, and they land on this other world, and there's DNA factories that build new human beings, and they go, this is a pretty great place. It's like super great. And it's just important to understand the difference between thinking of an idea and implementing an idea. And there's nothing wrong with thinking of fun ideas. Tom Hools. If Earth orbits around the sun and turns full circle around itself every 24 hours, shouldn't Earth then turn 180 degrees every 6 months compared to the sun, and therefore noon would be in the middle of the night? Tom, you have discovered one of the dark secrets of astronomy, and that is that a day on the Earth is not 24 hours. It actually only takes the Earth 23 hours and 56 minutes to turn once on its axis. If you measure some distant star and you measure some point on the Earth and you wait until that point on the Earth has come all the way around to now face that point in space again, it is 23 hours and 56 minutes. So why is a day 24 hours? Well, it's because it takes an extra 4 minutes every day for the Earth to turn a little bit longer to bring the sun back to the same spot in the sky. And so astronomers have two terms for this, right? The one, which is like how long does it take a planet to turn once on its orbit? That's called a sidereal day. And how long does it take for the sun to return to the same position in the sky? They call that a solar day. And they're two different numbers. And they can be vastly different depending on how quickly the planet rotates and how far away and how long it takes to be able to go around the sun. So congratulations, you figured it out. A day on Earth is actually only 23 hours and 56 minutes. Steve Peary. Hey Fraser, you mentioned gravity waves and lasers looking for them. Could future humans send messages very long ranges using gravity waves? What speed would be possible for those waves? Good news. Whenever you move, you are generating gravity waves. And anybody who wanted to would be able to use a very sensitive gravity wave experiment, maybe some super laser system, and detect your movements just by how you are rippling space-time as you move around. Of course, the amount that you are rippling space-time is infinitesimal. It's essentially impossible to detect. It's only when you smash black holes together, right? When black holes are about to collide and they're winding around each other and they're just, tangling space-time up into a knot. Only then can we detect the effect, the ripples of space-time. Now, there was the impact of 2 neutron stars back in 2017, and what this did was this told astronomers, because they were able to see the explosion and they were also able to detect the gravitational waves, it told astronomers that gravity moves at exactly the speed of light. So, in other words, if you wanted to use gravity waves to somehow communicate with somebody, those gravity waves would move at the speed of light. And so it's not really a faster way of communicating. Irivos85. Even if we had a way to provide power to a probe sent to another solar system, would the electronics, CPU, memory, etc., and the instruments on board still be in a functioning state after thousands of years? This is based on last week's question where someone wanted to know if we could have some kind of spacecraft that would power down and do a big long journey, and then when it arrived at its destination, power itself up. And I mentioned that you couldn't use the kinds of batteries, the kind of nuclear batteries that the current spacecraft use, they have too short of a half-life and they can't provide electricity for very long. Now, some people in the comments suggested some other kinds of decaying radioactive substances that might give you a longer lifetime. And so that's kind of an interesting direction to go, to think about, is there something that might give you 1,000 years or 10,000 years of power before it finally wore down? But you're saying like what about the electronics? And the reality is that we know that deep space, with all of the cosmic rays and all the radiation, can be hard on spacecraft. Spacecraft die. And so if you've got some spacecraft that is being pelted by cosmic rays and radiation and micrometeorites for hundreds or thousands of years, it seems like it's a pretty dangerous environment for it as well, especially if it's going fast, right? You've got some spacecraft that's attempting to go from the Earth to Alpha Centauri and it's moving at 10% the speed of light, then the dust that it's hitting it are like little bombs. So you would probably need to think of some kind of environment, like you would encase your spacecraft in a gigantic shield of ice or something that would ablate over long periods of time to keep that electronics safely inside of it. But I don't know if anybody's ever tried to think about how you could keep electronics or things like that last and work, start up again after 1,000 years. I mean, it makes for great science fiction where you find some old dusty factory that's been orbiting the solar system for 10,000 years or 1,000,000 years and you turn it back on again. But we're going to have to do some new engineering to figure this out. Caleb Gunkel. Hey Fraser, would it be possible for a sort of middleman to be launched to shorten the distance the signal of Voyager to continue communications with the Voyager? Where would this be if possible? Would it be worth the price? So the problem with communicating with the Voyagers is not the distance, right? Light moves at the speed of light, and the best line that you're going to get is to have a direct communication with the Voyager spacecraft. And so the Voyager has its transmitter, it sends its messages. We have huge receivers here on Earth that pick up those messages. So that's the most efficient way to send messages back and forth. But the problem is the gain, the amount of signal that you can transmit, because the strength of the signal that we receive here on Earth is very weak compared to what Voyager is attempting to send. So it makes sense to have some kind of booster. So imagine if you did have some spacecraft that was farther out into the solar system that could act as a relay point. Now, of course, the problem is that all of the objects in the solar system are orbiting around the sun. So maybe you put a relay out at Saturn, and so for half of the year, your relay is closer to Voyager than Earth is, and then the other half of the Saturnian year, it's on the other side of the sun, and now it's farther away, and so you can't use it. You have to use some different one. So, it probably eventually down the road, we're going to have a much better space-based infrastructure where you've got spacecraft all over the place that can send highly optimized signals back to Earth based on who's closest, who's got the best receiver, transmitter, all of that. But until then, it makes the most sense to just have gigantic dishes here on Earth that point out at the various spacecraft and communicate with them. Divine Evil. Hey Fraser, I want to start a YouTube channel and your green screen setup is so realistic. Can you tell us what equipment you're using? I hope it's not too expensive. Thanks a lot. Of course, this is the long-running joke here on the channel that we use a green screen, and of course we don't use a green screen. I don't know if you can see that. But the reason why it looks so great is there's sort of two parts to it. One is the work of my wife, Carla, to do the lighting. So we have, if you're looking to start a YouTube channel, the lighting is key. And I am going to show how we do our setup here. Let me see. So we've got one light on the right. It's a battery-powered LED light. Then we've got our camera, and then we've got another light, battery-powered LED. And then the camera leads to the microphone and the birds. Yeah. All right. So the lighting is the key, and Carla has got that absolutely mastered. I apologize. These starlings. I'm just gonna keep going. So Carla's got the lighting mastered, and that's a huge part of it, right? Being able to know how to operate the camera, how to work the lights. You can see my eyeballs. You can see two little dots in both eyes where the lights are bouncing. And so often, if you're looking at any YouTuber, any video production, you can pretty much tell what kind of lighting they have just by looking at people's eyeballs. You can see how many lights they've got. Have they got a ring light? Have they got an individual light? Wow. Have they got a ring light? Have they got one individual light? Have they got two lights? Have they got something more interesting going on? You can kind of reverse engineer it by looking at their eyeballs. So that's the first thing. Second thing is I really like the camera. It's a Lumix GH5 camera. We've kicked it into 60 frames a second and 4K, which is maybe a little extreme for me standing outside. But it's a great camera and a huge step up from a camera that we had before. But I think it's more important to nail the lighting and the audio than it is to really get a camera. And that way, you don't have to work on the green screen at all. You just stand in front of green things. What's that? Yeah. Yeah, Carla's saying she wishes she had a green screen so that we could stay at home during wintertime. But no, we go outside in the Canadian winter and shoot our videos. Jade, what do you think will be the big technology that will enable deep space travel? Solar sails, some sort of hibernation? What do you think is the most likely to have a breakthrough? I think that the technological advancements that are going to make the biggest difference for us is when we develop some kind of resource harvesting in space, like asteroid mining, extracting water and other things from space, from the moon, from asteroids, whatever, matched with some kind of space-based manufacturing. So something that can build solar panels in space, something that can create rocket fuel in space, whatever, something that will allow sort of humanity to have a foothold in space and get our robotic factories going and building things out there in space. And when that happens, then suddenly we are going to have this multiplier that goes on with space exploration. And it will be the technology that really supports anything else that we want to do out there in the entire solar system. Want to live in giant O'Neill cylinders? It depends on harvesting resources and manufacturing things in space. Launching stuff from the ground, from gravity wells, is incredibly primitive. And I'm sure Elon Musk would agree, Jeff Bezos would agree, that however advanced they're doing today, it is just a stepping stone to the real technology that's going to be actually out there and implemented in space to grow and maintain a proper infrastructure for us to become a true solar system civilization. So that's what I think it's going to be. Harvesting resources in space and manufacturing in space. Not so much solar sails. Bob Daniel. I like the idea of a habitable zone on a tidally locked planet where the dark side is too cold and the light side is too hot, but along the Terminator, it could be the proverbial just right. What factors could improve or work against the habitability of such a zone, like its width, or maybe the stability of the zone, affected by wobble, for example? Could evolution get started in such a localized area? Great question, and we've actually got a couple of extrasolar planet researchers coming up on an episode of the Weekly Space Hangout, and I did an interview with them for that, and I also got a chance to ask them your question specifically. So here you go.
All right, so this is a very interesting question, and this is one that I think astronomers and even science fiction buffs have thought about for decades. This notion that the day side, if you have a tidally locked planet and it's tidally locked into a synchronous orbit, you have a permanent day side, a permanent night side, and there's this notion that the day side will get really hot, and the night side will be really cold. And then there'll be this like Goldilocks zone along the Terminator, the day-night Terminator. So this idea, it turns out, is the basic idea is correct, right? It is indeed the case that on a tidally locked planet, the day side will be hotter than the night side, but it's not as big of an effect as you would think. And the analogy that I make here is with Earth. So if you just do the naive math and you look at how much energy is absorbed in Earth's tropics, you would find that Earth should be in a runaway greenhouse. So just like Venus went through. We should basically just evaporate all of the oceans and have a water vapor, like a pure water vapor atmosphere, and then we'd all be toast, or at least anyone living in the tropics would be toast. And likewise, if you live up here in Canada, if you do the naive math, we'd be frozen like all the time. basically. And of course, neither of those is correct. And what's going on? Well, basically the Earth very conveniently, or at least the atmosphere and the ocean conspire to transport heat from the hot place, which is the equator and the tropics, towards the poles. On Earth, that's the dominant sort of heat transport is happening from the equator towards the poles. That's because we have a rapidly spinning planet. And so basically all of the tropics are roughly the same temperature and the poles are all roughly the same temperature. On a tidally locked planet, it's instead this day-night temperature difference. But it turns out it's not that much harder to transport heat from the day side to the night side through both the atmosphere or the ocean. And so it turns out the day side of a tidally locked planet, it is hot, it's humid, but it's comparable to our tropics. It in fact looks very much like our tropics. It's very, you get, in our tropics, you get these tropical rainforests, right? And they're called rainforests because it's always rainy. Why is it rainy? Well, it's because you have this deep convection that's basically you're heating it so much and the air is rising. That's sort of one of the defining features of the tropics, in fact, is that they have a lot of incoming solar radiation. The other defining feature of the tropics is that the Coriolis forces are weak. Turns out that also applies to tidally locked planets. They're tidally locked, and so they're spinning very slowly, therefore the Coriolis forces are weak. So it turns out the entire day hemisphere of one of these planets is basically like the tropics. So just think of it as like being in the Amazon or something. So what does that night side look like? Well, it turns out the night side, it's cold, but it's not that cold. It's comparable to like Antarctica at worst, right? So like, yeah, that's terrible, but like, it's not like your atmosphere is going to freeze out or something, right? It's not like you're going to get like dry ice forming on the night side. So yeah, so basically it turns out, yeah, there's this kind of wide terminator swath that's like fairly habitable, but it's a lot wider than you would naively think, just because the ocean and the atmosphere is so good at moving heat around on these planets.
Thanks, Nick. That was awesome. You're going to be able to see Nick and his co-author in an upcoming episode of the Weekly Space Hangout. I think it's going to be sort of mid to the end of October. So this is like a really sneak preview of the episode. But it was great to be able to get him to answer this extra question. All right, that's it for this week. Thanks everyone who sent in your questions. I love this. As always, if a question pops in your brain, write it down. I'll gather them up and I'll answer them here. I'll see you next week.